Hi, welcome back. This is Professor Waits, and I'm talking to you about Chapter 15. And in this video, we're going to start out with constructors and deconstructors in the base and derived classes. So when you have a constructors and deconstructors inside of both your base and derived classes, they're going to happen in a certain particular manner. So derived classes can have their own constructors and deconstructors, while base classes can also have those items. When an object of a derived class is created, please remember that the base class's constructor is going to be executed first, then the derived class's constructor. It happens just the opposite when you destroy an object. When you destroy an object, the derived class is destroyed and its destructor is called first, then that of the base class. So remember, when you're creating an item, it's going to run the base class constructor first, and then the derived class's constructor. And just the opposite, when it's being destroyed, the derived class's destructor will call first, and then that of the base class. So they have a little bit of an example here where you've got a class, here is your base class, and they even called it derived class, which extends from the base class. Your base class has a constructor and a destructor, and so does the derived class. So when you instantiate this object, this derived class, the first thing that's going to get called is this, and then this, and then when you destroy the object, this will get called, and then this will get called. It has to do it that way because if you think about it, you want to make sure that when you are creating an object, everything that happens up here happens first, including maybe any memory pieces, things that are being put in memory, so forth and so on. Then you got the derived class here. Well, you need to first destroy any memory pieces you may have here, because if you don't, when you'd be out of scope and you wouldn't be able to erase those dynamic memory pieces. And then same thing with this class. That's why it goes backwards. And then this is the, you can verify that with this program output. So when you want to pass an argument to a base class constructor, you can always, it allows selection between multiple base class constructors. And the way you do it is you specify the arguments to the base constructor on the derived constructor heading. So this is, if you come up here and look at this, on this derived constructor heading, this is where we would put this additional information to call the base constructor. And you'll also notice that what we're saying is when you call this side, which is the square, which is obviously deriving from a rectangle because a square is a type of rectangle, it's going to go ahead and pass side into both params, which makes sense because on a square, the sides are equal. For example, maybe not the greatest example, but you can understand is what you're saying is, hey, when someone sends in this this variable for this square object, since we extend from rectangle, take that value and go ahead and pass it to the rectangle's constructor as side using both parameters of the same number. And you can do this also with inline constructors, and it must be done if the base class has no default constructor. So again, just a little bit of a nicer view of this. This side is going to be passed up into the base. Oh, sorry, right there. Yeah. So there you have constructor inheritance. In a derived class, some constructors can be inherited from the base class. The constructors that cannot be inherited are, and you may want to write this down, this may be on the test, and that is the default constructor, the copy constructor, and the move constructor. We've talked about these previously, so you should be well aware of what those type of constructors are. So this is that inheritance, and it's talking about a derived class versus a base class. And as you can see, the derived class is passing this int I into the base's constructor as well. And same for the second because you can do that. Remember, we have an int and a double, so that is enough separation to have two constructors. We can also rewrite the my derived class as using my base colon colon my base. This will automatically make it go right up to the parent constructor. Let's talk about redefining base class functions. So when you redefine a base class function, you are taking a function in a derived class that has the same name. This is key. It's the same name and parameter list as a function from the base class, but you're essentially going to reuse it. When you do that, the item in the derived class will be used rather than the item in the parent class. And this is typically used to replace a function in a base class with different actions in derived class. It's not the same as overloading. With overloading, the parameter list must be different, and we're not doing that. It's literally going to be the same footprint. It's going to have the same name and same number of parameters in the same order. And the objects of the base class use base class version of the function. Objects of derived class use the derived class version of the function. Because remember, you can still instantiate a class of the base type, right? Unless you've done something to make it to where you can't, you can spin up an object off of the base class. And if you do that, then it's going to use the base class's version of the function. But if you were to spin up an object based on the derived class, then it would use the derived class's version. So here we go. We've got a base class, and we have this set score. It's a void with a double S in that parent class. And here's the derived class. And as you can see, we have the same set score double S. It's just doing stuff differently. So there are definitely some problems with redefining. If you have a class base class that defines function x and y, and x calls y, and then in your derived class, you inherit from the base class and you redefine function y, then an object D of class derived class is created and function x is called. Well, when x is called, which y is used? The one defined in the base class or the redefined one in the derived class? So here we have that base class, which has both x and y, and then a derived class where we redefine y. But we make a class called derived class. We make a class D out of it, and we call x, which is going to call, by the way, this one. But it goes, which one should it call? Should it call this one, or should it call that one? Well, the answer is simply as they put it up here, that the x invokes the y in the base class as well. All right, so that is the end of this video. Again, we went over a lot of quick concepts, so go back and take a look at those and make sure you understand them. And then we'll see you in the next video where we talk about class hierarchies.